Hey, Jody here with weldingtipsandtricks.com. Today I'm going to build some TIG rod holders out of PVC pipe. I'm using 1.5 inch PVC pipe and a bunch of couplings and end caps, and that's about it. And I'm probably going to build a rack to put them right here. I'll keep you posted on that later on. But today I'm building the holders, and also I'm going to be talking about the 4 or 5 rods that you need starting out to handle most situations. Let's do it. Right now, I don't have any rental bottles. I own all of my cylinders, and I've probably got about 8 or 10 of them, and I just had to swap out 3 of them. I swapped out an argon, a 75-25 mix, and a pure helium, and these are the rates I pay to swap those out. If you'd leave your comments below in the comments section on what you pay in the area that you live in, I think everybody would find that pretty interesting. All right, well, let's get on with the build. First thing is to mark out the long piece, 1.5 inch PVC pipe, and I'm going to make a bunch of cuts at 30 inches. Now I'm cutting this thing on a Swag off-road portaband stand, which will cut plenty square enough just by eyeballing it, but I like to get a little bit of a mark, and I'm using this wide base square to do that, and I can mark almost halfway around it by following the wide base around with a pencil. And then once I get the blade in there a ways, it's unlikely that it's going to walk on me much. The portaband doesn't have an adjustment to tighten that blade up any as far as keeping it from walking. So, and I bought this this miter gauge along with it that slides, and it's going to come in really handy for just putting a stop on here and cutting all these 6-inch pieces. This is one handy little tool. I actually made a homemade one for a Porter cable saw, but now that I've got a Milwaukee, I decided to order one from Swag. And while I was at Home Depot, decided to pick me up a little Milwaukee fastback spring assist knife, and it's a fun little toy. I'm using it for deburring these ends of the PVC, and it's got a serrated edge on it, so getting the corner of that thing hooked in one of those little serrations, it makes for a good little deburr tool on stuff like this. And it wasn't too bad. I think it was about $30 for the knife, and that way you don't mind using it for anything and everything. I bought all the end caps and couplings that Home Depot had today, so I'm going to have to go back in a few days and buy some more because I need a good 5 or 6 more of these things to handle all the rods that I have, and then I'll still have rods in long-term storage. But I made them for 36-inch long rods. In other countries, rods may come a little bit longer, but all my rods are 36 inches long, so my overall length on these is around 38. Now, PVC can contain chlorides, and that is an issue on nuclear codes and things like that, but I'm not doing nuclear work, and I'm not really worried about chlorides getting transferred to my rods either. So this will work just fine. Now let's talk for just a minute about a list of rods that you probably need if you're just setting up shop. Like this will take care of most things that might walk through the door. You never know what's going to come, and then you have to go buy specialty rods, but this is a pretty good starting place. I bought my first Synchrowave 250. The first thing I needed was 4043 aluminum because I had work waiting on me. That's why I bought a welder. But you never know what's going to walk through the door, what kind of job, what kind of material. But these are a good list of rods, a good starting point. So I'm going to show now a list of sizes and types of rods and applications that I've used over the past several years. First up is 045. That's 1.1 millimeter ER70S2. Now that small rod really comes in handy even on something as thick as 1/8 of an inch thick or 3.2 millimeters thick, where you don't want to take the weld all the way up to the corner. You want to be able to run a really small bead. And 1/16, the 1.6 millimeter version of that rod, that's actually E70S6 rod there, which is not much different. If you want to add a little bit more, take the weld size up a little bit bigger, that makes that go better. And both of those sizes work good on chromoly tubing. And ER70S2 is a very commonly used rod for chromoly tubing. It's undermatched as far as the strength goes, but that's a good thing for applications like that. All right, here's an application where I use 3/32 on some high strength steel, some 4140 alloy that needed a 500 degree preheat and 160 amps or so, and 3/32 rod was just about right for that. I could have used a bigger one, but when you're trying to get down penetration into a chamfer like that, sometimes a little smaller rod helps, and you just would rather feed a little bit. And for the outside fillet weld, I actually ran 2 passes, but 160 amps with lay wire technique Ran that first pass in there just fine. And then a second pass to get the adequate fillet weld size was done with a 1/8 filler. Next example is ER308L, 045 and 1/16 diameter. A 304 stainless is one of the most commonly welded stainless steels. You're going to encounter that a lot. So it's welded with 308L typically. I don't even think you can find 304 because it's close enough in composition to 308 that they just sell 308 for welding 304. Now, the little tool that you're looking at there is just an old screwdriver with some silicon bronze welded and then shaped with a grinder and file. And it's a hold down tool because any gap in thin sheet metal like this will just mess you up big time. And by using this little hold down tool there, which like anybody can make out of an old screwdriver or even just an old piece of round stock, lets you hold the sheet metal to hold the lap joint together where there's no gap, and then you can get a really quick burst fusion tack that'll be smaller than your final weld, and that makes the job go a lot better. It's just really handy, and I use it all the time for thin lap joints like this. Holding it down with one hand and then holding the torch with the other, and makes the job go. You can get something tacked really quick that way. Now for a carbon steel job where you would use, say, 1/16 diameter wire, the 045 seems to work a little bit better for stainless steel. All right, for thicker stainless steel jobs, go up to the same alloy but a bigger size. Now this is a shaft that I welded a couple of years ago. It goes in some kind of food service poultry processing plant or something like that, and these ends had to be replaced, and so the first pass was done with a 332 rod, just dipping it in and out of there so that I could get good penetration up into that little groove there. And then after the first pass was done, came across it with a larger wire and weaved it. And the reason for the large weld there was because there had to be a radius turned on that shaft. A nice smooth radius was required. You know, in any kind of food processing plants, they don't want anything that'll trap bacteria, so everything's got to be smooth and without any crevices and rough places. And also showed a little bit in that same job of walking the cup on that second pass. And the reason for the knurling you see there was that was just a loose fit, and then they wanted to salvage that end shaft, so he knurled it so it would fit in there nice and tight while I welded it up. It's going to be turned down about 50 thousandths probably after the fact anyway, and so the knurling didn't show after the fact. All right, 309L, 1/16 is usually what I keep around for that, and it comes in handy for when you don't know exactly the grade of the steel you're welding, or you've got some crappy steel. Now I had a job to do replacing the ends on these molds, and I knew what the end pieces were because they were new, but I didn't really know the rest of it, and they had been repaired many times. Now this is nice new material here, but I also had to weld a bunch of them like this. It had a bunch of old MIG weld, and who knows what was in there. So the 309 just eliminated any surprises, and it doesn't bubble when you hit pockets of porosity in an old MIG weld like that. It has a tendency to not bubble and not get worse. Like regular steel, once you get porosity, it's kind of hard to cover it up, but 309 works really good for that. Not a crutch, not something you want to use indiscriminately all the time for critical welds, but it is a good choice for when you're not exactly sure the grade of the steel that you're welding, or if you're welding carbon steel to stainless steel. All right, 4043 aluminum is the most versatile kind of aluminum alloy to have as a TIG rod. You're also going to probably need some 53, 56, and along the way maybe some others, but 4043 is a good starting point, and having some small diameter rods like 1/16 or even smaller really helps on really thin sheet metal. Like this is 040, 1 millimeter thick sheet metal here, and you know, trying to weld this with a big rod just really makes it hard because an aluminum rod really draws heat out of the puddle too quickly, and you don't want it to chill the puddle too much. You can see even this small rod, every time I dab it in the puddle, because it's such a small puddle, you'll need to have some 332 diameter 4043 rods for anything, probably 80 thousandths and above. You could probably get away with using the bigger rod on, but once you get up to 11 gauge, that's 1/8 of an inch or 3.2 millimeter. The 332nd 2.4 millimeter rod is just about right. and also for even repairs like this. This is a mock-up, but it's very common to do something like this on a casting, to have to fill in a big gouge where something got, a bearing spun or a gear got loose or something. And using stainless steel backing, thick stainless steel backing, really helps to handle a job like that. And of course, you don't want to be feeding rod like crazy, so you want to use a 3/32 diameter or bigger. It's also good to have just a pound or so of silicon bronze laying around for little, ornamental jobs. Like this is a little malleable iron fitting welded to a carbon steel thing. I was actually making piggy banks last Christmas on this job. But silicon bronze is really good for art and also for little light duty fixtures. I've had really good results using aluminum bronze for cast iron repairs and on AC using alternating current, because it does have quite a bit of aluminum content in the wire, and so it muds up a little bit on DC. I prefer welding DC on silicon bronze, but AC with aluminum bronze. And this is actually a braze. I'm welding cold rolled steel here with aluminum bronze on AC, just flowing the metal forward and using just enough amperage to keep the puddle moving and no more than that.